5.3. Today we're going to talk about a new series called a geometric sequence. So right here it says determine whether a sequence is geometric. The sequence 2, 6, 18, 54, 162. So before we do that, recall arithmetic. Arithmetic is something like 2, 4, 6, 8, ... meaning there is a common difference. And again, we just think of that as linear. Here I can see that's going up by 4, up by 12. This would be up by 36. So already we can see that this is clearly not linear, right? It's not going up by the same amount, which means this information is not helpful. But I can see that we're multiplying something constantly, and that would be 3 every single time. So in that instance, what we say is this is a common ratio. The common ratio here would be 3, and if there's a common ratio, then we say the sequence is geometric. So for your notes here, we just studied arithmetic. We're going to add in geometric. Geometric is something like 2, 4, 8, 16, ... This has a common ratio, and essentially you're multiplying. So later on we're going to call this exponential. But for now, think of it as a ratio or multiplying. That's our main concept. So our next example says, show that the sequence is geometric, and there's our sequence. So let's just find the first couple of terms. Plug in 1, that would be 1 over 2. Plug in 2, that's 1 over 4. Plug in 3, that's 1 over 8. Plug in 4, that's 1 over 16. There's definitely a common ratio. Just look at the numbers and I can see that we're multiplying by a half every time. So our common ratio is 1/2. And since there's a common ratio, we can conclude the sequence is geometric. So now let's go to an example problem here. Find the nth term of the geometric sequence. So again, if you see nth term, that's just another way of saying find the general formula of this sequence. So we're gonna derive it. So I'm gonna reorganize our information here. The first term is 10. The second term is 9. The third term is 81 over 10. And the fourth term is 729 over 100. So hopefully we can recognize that every single time we're multiplying it by 9 over 10. But purely looking at this information isn't super helpful. So what I'm going to do is grab this and write it a little bit different. So think of this 9 as 10 times 9 over 10. So notice the 10's cancel out, and that would be 9. I'm just not reducing it. Now to get to the next number, we take this thing and multiply it by another 9 over 10. And now I think we're seeing a pattern. To get the next one, we multiply by another 9 over 10. So imagine if this were an n, it would be 10 times 9 over 10. Now look at the relationship. In the second term, there's 1 9 over 10. In the third term, there are 2 9 over 10s. In the fourth term, there are 3. So in the nth term, there should be n minus 1. So your nth term, your a sub n, is simply 10 times 9 over 10 to the n minus 1. So effectively what we just did is we made a formula. Let's put a box right here. This formula will apply for geometric series. And this is our general formula. To get the nth term, we simply take the first term and multiply it by your common ratio. That's 9 over 10 in this case, or you can see all those here. We call that r to the power of n minus 1. And again, we'll make a note there. That's your common ratio. So now let's use that to find the 9th term. So a sub 9, 10 times 9 over 10. Plug in 9, that's going to be 8. So we could use a calculator, but we'll just leave it as 9 to the 8th over 10 to the 7th power. Yeah, it's a pretty big number, so we'll just leave it like that. And then part C, find a recursive formula. So recall from our last video, a recursive formula requires 3 pieces. The first term, which is, in this case, 10. The second piece is the formula. So we need the previous term, multiply it by your common ratio. And the third piece, 4, n greater than or equal to 2. And there's a recursive formula. And we're done. Now let's go to our final question. It says a union contract specifies that each worker will receive a 5% pay increase each year for the next 30 years. One worker is paid $20,000 the first year. So our first term is given already, $20,000. What is this person's total lifetime salary over a 30-year period? So the second term is going to be $20,000. Now to do a 5% raise, what you want to do is you just multiply it by 1.05. So whatever this number would be the salary for the next year. And then to do the next year, just take that number, multiply it by 1.05 again. So effectively, think of it as like squared. And then we keep doing this to the 30th year. And at this point, this person has received a whole bunch of raises. So this should be to the 29th power. And the question would be to take all these things and add them. So clearly we could do this if I just want to plug in all these things individually, but that would take forever. So instead, what we want to use is the sum formula. Now, I could just show you the formula, but I'm going to derive it for you here. So I'm going to write geometric sum formula proof, and then we'll use it after this. So we're going to write S sub n for the sum. This is some generic formula, or some generic sequence. Let's call the first term A1. The next term would be A1 times R. The next one would be A1 times R squared. And this continues all the way to n. A1 times R. Actually, I'd say n minus 1. So this is your nth term, but notice how it's n minus 1, because our first term doesn't have a single R. Right, so this whole thing has n terms. What we're going to do is a pretty cool math trick. We're going to multiply this entire thing by R. So imagine you did that. You get R S n. That would be A1 times R plus A1 times R squared plus A1 times R cubed. And this continues. And that's the cool part. The second to last term should be A1 times R at n minus 1. And the last term should be A sub 1 times R to the n. Because if you multiply this by R, this power should go away. So you have this piece right here. Now, what we're going to do is take these two things and subtract them. And that seems kind of weird, but watch what happens. S sub n minus R S sub n equals, I have A1 here. There's no single A1, so that just stays here. But this is pretty cool. These two things are going to cancel. These two things are going to cancel. These two things are going to cancel. And the canceling keeps happening. Cancel. All the way up until the final term. So all we have left are these two things. So minus A sub 1 R to the n. And now I can solve for S sub n. So S sub n is equal to, let's factor that. That's 1 minus R. And I'll factor out A1. That's 1 minus R to the n. And there's our formula. A sub 1 times 1 minus R to the n, all divided by 1 minus R. So there's our sum formula for the geometric series. So now what we're going to do is use that formula here. We want to add up this person's 30-year salary. The first term is 20,000. We're going to multiply it by 1 minus R. The R is 1.05. That's to the 30th power. And divide this by 1 minus 1.05. You plug that in your calculator, and this is the amount of money we'd have. 1,328,776.95. So this would be the person's lifetime salary.